Everyone, good to see you. We have a lot to do today. We are talking about these concepts of vectors. Before we get to that, let's review the four parts of a vector. There are two rectangular parts called components and two polar parts called a magnitude and a direction. Remember, the magnitude is the hypotenuse. There's a vector. Pause the video, see if you can write it in both polar and rectangular or component forms. It is a polar vector, so you really should be able to write it in polar. And the components are found by sine and cosine. And cosine always gives us x, and sine always gives us y if a side of your triangle is the x-axis. Now, when you write your components, make sure that if something's negative, put the negative in. This is in the third quadrant. So put a negative for both x and y. You just have to observe that. Number two, keep in mind at Socrative, if I ask for anything, whether it be polar component forms, that's what I mean. All right, see if you can do that. Since it's a rectangular grid, you really should have no trouble now coming up with that. And then the magnitude is the hypotenuse, so we just use the Pythagorean theorem, which you've been doing for years now. And then everybody in here can find theta, but we want alpha. You find theta by tangent inverse and then subtracting from 180. And there's your polar coordinates. You could make that a decimal if I asked for it at Socrative, or you can make it root 73. That's just how nice I am. All right, let's move on. All right, vertical and horizontal vectors, we all love these because you just interpret them. There's no calculations. You don't use sine, cosine, tangent, the Pythagorean theorem. Let's look at one. All right, component form. You can get that as 0, -6. Just count down. 1, 2, 3, 4, 5, 6. And polar would be 6 in the direction of 270. You observe the direction. Don't do tangent inverse. You're just going to get messed up. Don't do it. Number 4, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's -9, 0. And the polar would be 9 in the direction of 180. Happy. I'm happy. You're happy. Observation, observation. Vectors from points. Now there's two vectors could be drawn here. We could go from A to B or B to A. Let's just look at B to A. So we're doing the one on the bottom. We could do it the way we've been doing it. We could go 9, 2, and that would be -9, 2. Or we could subtract the coordinates, but you have to subtract the end minus the beginning. So the end is A, and so for the x coordinate, we could do that as -4 minus 5. You subtract the coordinates to get the components. And then do the y. That would be 3 minus 1 is 2. And so we'd get -9, 2. It's the end minus the beginning. In a situation like this, you could get yourself some graph paper and you could graph those points and sketch it. If that's what you want to do, then fine, do that. But at some point, you're going to want to do end minus the beginning. So the end is B. So it'd be 21 minus -4 is 25. And then -15 minus -8 is -7. It is that simple. Number 6, see if you can get that right. The end this time is A, so it'd be 0 minus -8 is 8. And 17 minus 14 is 3. At Socrative, number 6, if I ask for that, that's what I mean. No spaces, please. Adding vectors. We have seen this situation where I had an airplane and some wind. We hadn't quite finished it up, but that's what we're doing today. You might be thinking again, well, I'd rather just interpret this as polar, not rectangular, but not going to help you. Let's look at why. Here's a situation where a dog is being pulled on by two people. I don't know what they're trying to do to the dog. They're not hurting it. Don't call the Humane Society. But Bob's polar vector is 12 in the direction of 180. Steve's polar vector is 10 in the direction of 0. If we added that to that, we'd get that, and that to that, we'd get that. But then you'd have to interpret the result over here. And that just doesn't interpret right. If you should be able to look at that and say, you're right, it doesn't. If you can't, give me a call. If we looked at it in component form, Bob is negative 12, 0. Steve is 10, 0. And their resultant is negative 2, 0. And that makes sense. That's what we have to use. Vectors can only be added in component forms. Here's another example. Let's say they're pulling in the same direction. Bob would be 12, 180. Steve would be 10, 180. And the resultant would be 12, 360, 22, 360. Well, that's going this way. That makes no sense. If we looked at it in component forms, Bob negative 12, 0. Steve is this. The resultant is that. And that makes sense. Vectors can only be added in component form. Here's a situation that we will see from time to time. I went ahead and did U. Let's do T together because it's fun. So that's negative 7, 4, and that would be negative 2, 3. Almost done. Number 8. So we could do it in this situation where we'd come up with vector BA by doing the end minus the beginning. Let's do it here. So that would be B minus C, be that minus that is negative 7. And that minus that is negative 28. And then you add the pieces. So it would be negative 4, negative 1. All right, we have one more problem. That is going to take some time to get through this. Let's read it. In still air, a plane would be flying at 600 in the direction of 220, but a crosswind is blowing at 40 in the direction of 127. It seems like we could just go 600 plus 40 is 640 and be done, but that's not the case. We've got to get it into components, both the wind and the airplane. Let's do them one at a time. Pause the video and see if you can do the wind. There's the setup. If you don't understand where the 53, the X and Y are coming from, call me. All right, we find X by cosine and Y by sine because a piece of our triangle is the X axis. And then we would apply a negative to what needs to be negative. In this case, the X component is negative. Let's do the airplane. Pause the video. See if you can do the components of the airplane. There's the setup. There's X. There's Y. Let's make anything negative that needs to be negative. See if you can decide that before I light it up. They're both negative because we're in the third quadrant. Getting towards the end, I want you to familiarize yourself with this setup here because I'm going to give you that from time to time. But the magnitude of the airplane is 600. The magnitude of the wind is 40. The direction of the airplane is 220. The wind is 127. And it seems like we could just say this plus this is 640, but we cannot. We had to put the components, get the components of the airplane and the wind. And that was them. Now we say this plus this is this. And this plus this is this. Okay. Now, guys, I'm going to leave this right here with you. What is the magnitude of both the wind and the airplane? You use this and this to get it. And what is the direction of the wind and the airplane? And again, you use these two pieces. That will be at Socrative. I will ask for that because I love you so much. All right, guys, I miss y'all, and I'll see you later.